Hello friends, in this one let's take a look at solving this little puzzle. So what we have is the following. Suppose f of x equals x cubed plus bx squared plus cx minus 3. And then suppose further that y equals 42x minus 75, just some random numbers, is tangent to the graph at x equals positive 3. Basic question, find the values of b and c. So how can we go about solving this? A way to do this is as follows. Remember that when you say that this is tangent, so y equals 42x minus 75, that's like saying that the value of the derivative at x equals 3 is 42. That's what that tells us, okay? In other words, slope of tangent line is 42, so that's like saying that f prime at 3 is 42. So differentiate next. When I do that, I'm going to have 3x squared plus 2bx plus c using the power rule on the function. Just keep the b and the c as they are. So what I'm going to do is the following. I'm going to take this expression above my head there and basically just evaluate it positive 3. So we'll have f prime of 3 equals 3 times 3 squared plus 2 times b times 3 plus the c. Simplify that, so we'll have 27 plus 6b plus c. Then you set that equal to that value of 42. Remember, that 42 is the value of the derivative at 3. It's also the slope of the tangent line. In other words, it's the coefficient right there above my head, okay? Don't forget that. So when I do that, I'm going to have 27 plus 6b plus c is equal to 42. With that in place, next, that's not enough because you see this has b and c as two separate parameters, okay? Two separate variables. You have to solve for them. So that's not enough because we have to find b and c and we have only one equation. When you have one equation and two unknowns, you can't solve that for both of them as numbers in this particular case. So what I'm going to do is the following. I'm going to find f at x equals positive 3 also. So that's like saying f of 3, in other words, it would be equal to 3 squared plus b times 3 squared plus c times 3 minus 3, simplify. 3 cubed rather, that's what I meant to say, is 27. Then it's 9b plus 3c minus 3. From there, remember that I can get the value of the function at 3 by also looking at the value of the tangent line in terms of its y-coordinate at 3. So for that reason, I can do y of 3 equals 42 times 3 minus 75, which is 51. So that's the value of the y-coordinate where the tangent line meets the graph. Therefore, it's also the same, basically, y-coordinate as the graph. So I know the value of the function at 3, in other words, you see? It's 51. So what does that allow me to do? Well, what I can do is this. Set the result of step 5 equal to 51, since the y-coordinates must match. What I mean by that is the y-coordinates of the tangent line, essentially, and the function. In other words, it's going to give me 27 plus 9b plus 3c minus 3 equals 51. Okay? Good. So remember that looks like that. Next, let me zoom down a little bit here. So now I'm going to get a system. Now the system looks like 27 plus 6b plus c equals 42. So that's from step 4 above, if you look carefully. And I'm going to have another equation, 27 plus 9b plus 3c minus 3 equals 51 from step 7 above, okay? So I've got a system of two equations. Now I can find the values of b and c as numbers. So put all the constants on the right side. So I'm going to do 6b plus c equals 42 minus 27. 9b plus 3c equals 51 plus 3 minus 27. Simplify the right sides of those equations. So I'm going to have 6b plus c equals 15 and 9b plus 3c equals 27. What I'm going to do to continue is I'm going to take equation A, which is 6b plus c equals 15. I'm going to multiply by negative 3. That's going to give me negative 3 times 6b plus c equals 15. Why am I doing that, by the way? Well, it's simple. It's because in equation B I have a positive 3c. And I want to be able to add the equations and cancel one of the variables. So I'm going to have negative 3 multiplying 6b plus c equals 15. When I do that, I distribute the negative 3. It's going to be negative 18b minus 3c minus 45. Good. Now with that in place, I'm going to add my equations. Specifically, it means the following here, okay? I'm going to take 6b plus c equals 15 in its modified form, negative 18b plus, oh boy, minus 3c minus 45. I'm going to add that to 9b plus 3c equals 27. And now this line above my head, that's not meant to go through that equation. It's just a printing mistake. So pretend it's not there. Okay? What I have therefore is the following. 9b plus 3c equals 27 plus negative 18b minus 3c equals negative 45. When I add them, it's 9b added to negative 18b is negative 9b. 3c with negative 3c is 0. And then, of course, here 27 plus negative 45 is negative 18. And then, of course, you divide both sides by negative 9, and it's going to tell you that b equals 2. I've made progress. I know the value of b is 2. Perfect. Next, I'm going to now use this value of b equals 2 and proceed as follows. That's step 14. Plug b equals 2 into equation A from above. So that's basically step 10, equation A, which is 6b plus c equals 15. Just replace that b there with 2. It's going to give me 6 times 2 plus c equals 15. That's 12 plus c equals 15. Subtract. So c will be equal to 3. Lastly, I put my pieces together. In other words, the function specifically that I am looking for is x cubed plus 2x squared plus 3x minus 3 is the function with a and b now replaced with their specific numerical values. Let me just try to zoom out and see whether I can show you all of the work. It may or may not be, readable. It depends, but this is all of the work from top to bottom. I think it's probably still visible on the screen for you if you need to trace it. Oh, you see, a little bit is still missing. Oh boy. Okay. I hope you can see it all. Thanks so much for watching. Please leave a like and subscribe. I'll see you in another video.